Okay, so we have really done some really great work with factoring polynomials, finding that greatest common factor of that polynomial. I think we found that it's actually kind of easier than working with just plain old numbers because you really don't have to remember as many factor pairs. We've got a couple more examples to look at, and I know one of them is going to be an application, but this one is not one of those. This is actually kind of a nice one. Some really nice numbers, some really nice combinations of exponents. So this is going to actually factor out really, really, really well. But I want to use some cool colors. So let's see, let's use this darker green to factor this first one. We've got 15, we've got x cubed, and we've got y squared. Well, 15 can be 3 and 5. X cubed is x and x and x, and y squared is y times y. So here are our prime factors of 15, x cubed, y squared. Now, I usually don't use those two colors together, but I will anyway. Let's factor this 10x squared y to the fourth. We have 10, we have x squared, and then we have y to the fourth. 10 we know is 2 times 5. X squared is x times x, and y to the fourth is going to be a little bit, excuse me, I'm just going to do something just a little bit clever here. I'm going to say that y to the fourth is the same thing as y squared times y squared. And then we can say this is y times y, and this is y times y. Why did I do that? I'm not really sure. I actually probably could have left it as y squared, since we have this y squared here also. But I'm not going to change the rules. I want to make sure we break everything down to the simplest it could be. That's the essence of prime factorization. So, our prime factors here are 3 times 5 times x times x times x times y times y. And then with the red, we've got 2 times 5 times x times x times y times y times y times y. Okay, so now search for common factors. Well, we have a 3 over here, but not in the other term, but we do have a 5, so that's good. Got an x and an x. Got an x and an x. I've got an x, oh, no x. I've got a y and a y. I've got a y and a y. And that's all I've got left. So, my greatest common factor is going to be all this stuff multiplied together. 5x squared y squared. So to factor this out, we take our greatest common factor that we just found, 5x squared y squared, and then with everything else that's left over, times 3x. Plus 2y squared. And there we have it. We have just factored that binomial. Now we have a monomial times a binomial. So it's pretty straightforward. And notice I've done the same thing time after time after time after time. The pattern doesn't change. So let's take a look at another situation. We've been talking about factoring out monomials, right? But we can also do that, factor out binomials. So let's take a quick look at this one. One of the things we need to really remember is that if something is in parentheses, we have to treat that thing as if it were one thing. So these x plus 3's are just x plus 3's. They're not x's, they're not 3's, they're x plus 3's. So, I mean, if we want it, I'll show you a way we can make it a little bit simpler, or a little bit clearer, but it might be a little bit more confusing. So, but let's take a look here. We are still going to prime factorize. We are going to prime factorize this into 7 times x plus 3. And then we're going to factorize this into 5 and x plus 3. So let's write out our prime factors, which isn't going to look too different than what they already are. So we'll have 7 times x plus 3, and then 5 times x plus 3. Look for all the common prime factors. There's only one, x plus 3. So our greatest common factor is x plus 3. So when we factor it out, we put it in the front, and then whatever we have left goes inside the parentheses. So we'll have 7x minus 5. We just factored out a binomial. That was pretty cool. And that's going to be a really neat trick come something else later on, maybe in Algebra 2 even. But so keep this one in the back of your mind. Okay, to factor out binomials. It's actually kind of makes you feel real good. Actually, I think so. So let's look at one more example. It's a geometry example. Here I even gave us a reminder of what the area of a rectangle really is. I'm actually going to do this with a drawing. Whenever I have geometry questions, I always like to draw. I don't know why. So I'm going to draw a rectangle. And I am being told that the area is 6x plus 4. And the width is 2. So we need to find the length. I'm just going to call that L. So let's use our formula for the area of a rectangle and do some substituting. So we know that the area, A, 6x plus 4, is equal to 2 times something. We know the L is length, 2 is the width, so it's 2 times something. So we are looking for L. We are looking to solve for L. Okay? So that means we need to get everything away from the L. So we do that by dividing by 2. Now remember, if we're dividing by 2, we need to divide everything by 2. So this would become 3x plus 2 equals the length. So the length of this rectangle is 3x plus 2. Whatever x might be. We don't know what x is. But if we did know what x is, then we would certainly know. There's a kind of another way that we can do this dividing. As we've been practicing, we've been talking about dividing by that number, by that coefficient. I'm actually going to tweak it just a little bit, and it might make a little bit more sense if we think of dividing by 2 as the same thing as multiplying by 1/2. So if I've got this 6x plus 4 equals 2L, and then if I multiply that by 1/2, multiply this by 1/2, then now all I need to do is use the distributive property. So I've got 6x over 2 plus 4 over 2 equals 2L over 2. Now we see things a little bit clearer. If we're still happy with division, we just have to remember that we have to divide everything on both sides. Just like we have to multiply everything on both sides. So if we have an area and a width, we can find the length, even if there are variables involved. And the variable just means it's a number that we don't know, so we don't know really how to treat it. All we know in this case is that we're going to multiply it by 6. Some number multiplied by 6. Increased by 4. Okay, cool. So that was basically it. This one is I like because actually it's kind of the story of my life. I'm a huge procrastinator, as you could probably tell. I promised you a recording a week ago and you didn't get it until now. So it is true. You cannot escape the responsibility of tomorrow by evading it by today, which kind of means don't put things off to the last minute, because not only will you be not escaping it, but you're going to be actually exacerbating it. You're going to be making it worse, because now you've put it off and you have less time to do it, and now you're under pressure, and now you're stressed out, and now you start puking and all that fun stuff, and you can't get the work done. So it's basically the same kind of thing as never put off to tomorrow what you can do today. So this is like the last Abe Lincoln. We'll be looking at another quotester next week. And I hope you have a great day and a great weekend and all that other fun stuff. Thanks a lot, guys.